Today we're going to start the process of another Klipper install. But this isn't just a regular firmware install. This time we're going to go deep. Hello everyone, Chris here. Yes, we're going to do another Klipper install, but this time we're going to go all the way from start to end with a printer that's up and running on our new mainboard. This time we're going to be using an MKS Makerbase board. It's one of the larger boards that has a lot of different driver options, as well as a Raspberry Pi-like environment baked right on the board. So to run Klipper, you don't have to have an additional small board computer of some kind. And this whole install started with my buddy, Thom Llama.
Hey Chris, check out this Skipper board that's supposed to run Klipper and have the Pi built on it and everything. Cool, huh? Now what the f am I supposed to do with it?
So I think Thom is in the same boat that a lot of folks are. They want to run Klipper, they don't want to have to mess with the Raspberry Pi, so they want to use one of these boards that has it integrated on it, but they don't have all the bits and pieces of information they need to get that done. And it's not just the install part, it's all the different options you have, things you can decide to do or not do to make this happen. And I'm going to try to include as many of these things possible in this video series. Yes, I said video series because it's definitely going to take more than one video to get all of this completed. Now, I think there's four main sections we need to be worried about here. There's the board and getting to know the hardware and the options you have. There's the Linux install for that Raspberry Pi setup. That's a different piece of software altogether. Then there's the Klipper install, and then there's the Klipper configuration on whatever hardware you might be using. So I'm going to try to divide it up where it makes sense so the videos aren't too long, and we're going to get all of this done. So let's get started by taking a look at the board we're going to be using for this project, then we'll move on to that Linux install. For this project, we're going to be using the Makerbase Skipr. The reason why I decided to go with this for these videos is because this is the board that Thom has decided to use, and you can get them on Amazon for around 35 bucks. That's a lot of bang for your buck here. You can support 7 drivers. And the board for this is not all that you're going to need for this install. At the very least, you're going to need some drivers and some SD cards to make this happen. Remember, you have to have a card for the OS for Linux, as well as one to flash that MCU. So the board side, or the 3D printer side of this whole thing. And just to get it out of the way, I will be using Makerbase branded TMC 2209s. Makerbase furnished these for this project. So let's just see what this board has to offer for 35 bucks. We'll just go around like we usually do and see what features we have. So we'll start up here. We have 3 always on fans, and then you have 3 controllable fans. Down here you have a set of jumpers. You can control what voltage all of those fans would be running at. 5, 12, or 24. I did mention it already, but we do have 7 spots here where we can load a driver. They have all the pins to configure them in standalone, and it does support UART mode. And you do have parallel plugs for the Z motor as well if you want to run 1 driver, 2 motors. Down here you have all your temperature sensors. It can support 4 heaters. That's 3 hot end, 1 bed. Then you have all of your end stops. So 3 minimums, 3 maximums. You can use those pins for other things. You just have to change it in the configuration. Over here you have diag pins, so you can control how centraless homing works if you have that option on your driver. You have pins for the regular LCD display if you choose to use it. So these are just EXP1 and 2 like other 3D printer boards would have. And you have some pin options down here for touch screens, things like that if you want to use it. And we'll just hit some of these other ones. You have CAN bus right here if you want to use that. You have the host USB interface, that's USB-C. You have the host TF slot. That's for the Linux SD card. We'll jump back a second. This is for the TF slot. This is the SD card for the MCU load. And this is the MCU USB interface. So if you needed to plug into a terminal and send it to commands, this is where you do that. You have HDMI out. You can use a screen. They do have HDMI screens you can get. You have an Ethernet adapter if you don't want to use Wi-Fi. One of the important things to note here is you don't have Wi-Fi automatically. You would have to use a dongle of some type. You have USB 2.0 and 1.3.0. Down here you have a Pi TS35 FPC interface. as well as for pins for your accelerometer and some reserved I/O pins that you can use in the configuration. Power input, 12 volt through 24, as well as heated bed. Both of those are fused and they're removable. Then you have all of your heaters. This is HE0, 1, and 2. On the host side of the house, or again, representing something like a Raspberry Pi, you have a rock chip here. That's a Cortex A53 ARM processor. You have 1 gig in these 2 chips of DDR3 memory. Again, you have the option for that TF card over here, but you also have this eMMC. Basically, it's just a flash drive you can use. So you have options. You can flash this one here, or you can keep it on the TF card. We'll try to do both. You do need a special adapter for this. And then over here on the board side, the 3D printer side, you have your MCU. This is an STM32. It is an F407 Cortex M4 architecture, 168 megahertz. So there's a whole lot of features on this board. The only thing I don't see on this board that I see on others is the option to use 48 volt direct for your motor drivers. Probably not a lot of folks doing that out there, but keep in mind this one does not have that option. So there's a look at the hardware. It has a lot of features for a very low price. But now we have some decisions to make. First up, with Klipper, we expect to be able to connect to this install via the network. So we have to have some sort of connection. If you want to use an Ethernet cable, you're good to go right out of the gate. Linux will be able to do that. If you want to use Wi-Fi, you're going to need an additional dongle, and not all of those are the same. Consult the Makerbase Github for the models they recommend. Some of them will work, but not all of them are going to be that performant. And I'm going to test a couple here to try to get you a link to the one that I think works best. Next, we have to talk about SD cards and this eMMC module where we install Linux. You can go either way. If you want to use that eMMC, you're going to have the adapter. It should come with the board, but I don't know that for a fact. So consider that when you're making this decision. I'm going to try to show you both installs. So let's get into that part now. So for the next step, we're going to load up Linux, and we do need an SD card. For the Linux, I've got this 32 gig SanDisk card. It has to be bigger than 8 gig. And then I've got this 8 gig card that I can use for my MCU. That'll come a little later. So we'll mount this card on the computer. You'll need some sort of tool like the Raspberry Pi image tool or etcher to get this done. I'm going to use the Raspberry Pi tool. But then we can just head over to their GitHub. I'll actually go back to show you how to navigate. Here's the main Makerbase GitHub page. Just go to repositories. And we've got a Skipper board today, so you can just search Skipper here. And here's the repository. And they do have a pretty straightforward set of instructions here on how to get all of this done. But the first thing we need is some sort of Linux image to be able to do this. So we'll just scroll down. And they take you to a Google Drive. So here on the Google Drive, you have several options. I would just go with the newest one. Now, I have tried many different versions of this that they have out here. Some work, some don't. So you might have to try more than one. We're going to go with the one that was built on July 27th, 23, because I know that one does work. So we'll go ahead and download that. Once the download is complete, you will have to extract it. You can just right-click the folder, hit Extract All. That will extract the image file we need to load on the SD card. Once your image is extracted, make sure you have your SD card mounted. Remember, it needs to be somewhere larger than 8 gig. We're going to use the Raspberry Pi tool. You can use this for anything, not just writing Raspberry Pi images. But we'll go to Operating System, use Custom, and we'll select that image we just extracted. We'll choose our OS, select your SD card. Remember, it's going to overwrite anything that's on it, and we'll hit Write. You don't need any custom options here. They're not going to work on Armbian, but we'll deal with that later. Just hit Write. And here's the point where I get just a little bit frustrated at these boards that have these Raspberry Pi-like environments on them that have these Linux installs. They're all using some version of Armbian, but they've taken a distribution, tweaked it so that it will work for this specific board. And it seems like all of these companies are doing that. What needs to happen is they need to share what they've done inside Armbian with the Armbian project out there on the web. That way, we can build it into some sort of specific distribution rather than having to go to some secret Google Drive for each one of these companies to get an OS that'll work with this board. It wouldn't be that hard to do if they just share the changes and let some of the users tweak it to their liking. Then we'd have a solid distro. I really hope that happens because it is very aggravating to me that you have to run around and get all these very specific ones for each board you want to use. Okay, off the soapbox now. we'll go back to installing Linux. The SD card write is complete. Now we can take it over to the board. We're not going to use it quite yet, but let me explain. So we got our SD card made with our image, and I'm going to do my best here to not jump around so much, but there's just a lot to this. So we need to get the board powered up, and no matter what way you go, either Ethernet or Wi-Fi, we have to cable up to a computer to be able to configure this. If you got the eMMC module, it should already have the OS flashed on it. But again, I want to show you how to use this module if you need to flash it, as well as the SD card. So we're going to do multiple things here. But just to get started, we're going to have some sort of external power supply to power the board up to even talk to it. It will run at 12 or 24 volt, but you have to have that power supply cabled up over here before it will even power on. So we have our external power supply, we're plugged into our computer. Now we're going to head over to the computer and log into it so we can start looking at the configuration. So over to the computer, we're going to have the PuTTY tool to log into that board SSH. Keep in mind there are multiple USB-C ports on that board. Make sure you're using the one that I just showed you. We're going to open up PuTTY. Our next challenge is we have to log into this serial. To use serial, you have to know your COM port and your baud rate, and this is not a standard baud rate. On Windows, I know Tom has Mac, but on Windows, there's a pretty easy way to find out the COM port. We're just going to open up Control Panel. We'll go to Hardware and Sound, Device Manager. And when your board's plugged in, you should see COM ports right here. We've got our device at COM7. Now note also, this says it's a CH340 device. To use a CH340 serial device, you have to have a CH340 driver. I already have one installed, but if you don't see your board, you need to install one. They're pretty easy to find out on the internet. You can usually just search CH340 driver Windows, and there's going to be a lot of different articles. Sparks of Fun is always good. They're going to tell you a lot of good information about what the CH340 is, but then they'll offer you this driver. I will leave a link to this driver. You can just download it. It's a quick executable. It's going to find it. Just hit install. It'll find your device. You'll be good to go. Now I know there's a lot of pieces to this, but now that you have your driver installed, we know what our COM port is. Back to PuTTY. We have serial selected. We're on COM7. And the baud rate is not a standard one. It's 1.5 million. So 150000 and then one more 0. And hit open. You might see some information here that doesn't look right. Just hit enter. You might have to do it a couple of times, but then we're going to have a login. I'm going to make this text just a little bit bigger for you. Your login will be root. And the password is Makerbase. All one word, lowercase. And now we're logged into that eMMC module where Linux is installed. This is the install they did from the factory. You notice we have some packages to update, all that good stuff. One of the main reasons why we're getting in here to do this, you also need to configure Klipper, but we need to know the IP address of this board so that we can utilize it. Right now, we don't have a Wi-Fi module, but you can just do ifconfig. That's going to show you the Ethernet module. If we had a cable plugged in, it would show you the IP address. So that way you know where to go with your web browser to access your Klipper install, whether you're using Mainsail or Fluid. So we don't have an Ethernet cable. I want to use Wi-Fi. So I'm going to start with this module right here. Again, I'll try a couple. I'll leave the links to the ones that work the best in the description. But I'm just going to plug in the one I have to a USB 2.0 port here. And then we can go back to PuTTY to configure it. Most of them are going to have an indication light, whether they're working or not, but they're not going to be able to connect to the network quite yet. And some tricks that I want to show you to help configure these, because these can be really tricky. I've had a lot of these work, different distributions work, some don't. It's just kind of all over the place. But when working with these Wi-Fi modules, it has to install a driver. And Linux is going to be able to do that, but not for all devices, depending on the distribution they used. So what I like to do is just tail the log file. So I'm going to do tail-F/var/log/message. Messages with an S. So this is pretty much just the system log. I'm going to go ahead and plug that Wi-Fi dongle in again so you can see what happens when it loads a new device. So you can see that it knows something about the USB device, and it has a MAC address, but you don't know that it's actually become ready. And this is probably way too much information for a 3D printing board video. I'm just trying to give you the idea of how to troubleshoot things. So when we're looking at messages, you could also tail var log syslog, but that's going to give you a ton of info, but it might be helpful. So we'll just go ahead and tail it just like we did before. And while we're watching it, I'm going to go ahead and unplug and plug the Wi-Fi dongle back in. We're going to see a lot more info here. WLAN disabled, we're going to put it back in. It tells us about the chip. If you need to use a specific one, this is what you want to compare up to that GitHub over on Makerbase. They tell you which one they prefer. And WLAN is enabled. Now we need to configure this adapter. The easiest way to do that is with armbn config. So we'll just Control C to get out of this, and we're going to do armbn-config. It needs the internet to do certain things, but you can continue. Just hit any key. And the menu is kind of wonky. So do your best here, but we need to get to network. And in here, we should have a listing for Wi-Fi, but we don't. And I see this all the time. So we'll just exit out of that config menu. Sometimes all you really need is a reboot. You can do sudo reboot now. That'll get things cleaned up, and then you can see the Wi-Fi module. We'll get logged back in. If you do that if config, you should actually see the WLAN module. There it is. And then we'll try that armbn config again. And after a reboot and plugging in and unplugging the device a couple of times, we now have Wi-Fi. It's not very straightforward. Hopefully newer releases of this distribution will help that. But for now, manage Wi-Fi network, select the network you want to join, and then enter your password. Remember, these are case sensitive. And just hit enter. And if you can see the menu well enough, go down to quit, and then you can go back and exit. So now if you do ifconfig, you have your wireless LAN interface, and you have an IP address. Now, this install from Makerbase, it already has Fluid and Klipper installed on it. So at this point, you can access it via either your Ethernet cable or your Wi-Fi, and you can go to this address. So we just went to 192.168.1.23. Here's Fluid. So Klipper, the Fluid install, it's already been done for this board. Now, we're not going to leave it like this. We want it to be a little bit more involved. So we're going to deep dive on a few other things before we continue. And while we're still on the topic of images, no matter if you're using the SD card in this slot here or your eMMC, the process is the same. Remember, they did have a version installed on here from the factory. If you were using that eMMC, we have the newest one on the SD card. I do know that works. I've tested it. But what if you want to write a new image on your eMMC? There's just two tiny screws. You can back those out and lift this off. And if you get one of these, they should give you an adapter. The adapter looks like this. It has a socket on the back. It tells you which way the adapter goes. It should fit like this, and then you can just put this in your micro SD card slot, just like we did with the SD card. So we'll just mount it on the computer. To your computer, your eMMC is going to look exactly like the SD card does. Here it is right here. You can just go to your Raspberry Pi tool, grab that same OS, choose storage. There's our 8 gig eMMC, and we'll just write it. So same exact process. Now you can just take this back to your board, plug it in, boot up. Now you're using eMMC versus SD card, whichever one you want to do. One last thing I wanted to touch on for this video is they mention all these different Wi-Fi adapters. Some of them could cause performance problems. Now, how do you know that? Well, your board would become pretty sluggish while you're using it, while you're trying to interact with it, maybe uploading a file, but it's pretty easy to tell. Some of these have a bug that cause the performance to be really bad. They start using a lot of CPU instantly. You can see in our ifconfig, we have our Wi-Fi adapter here. I have tried a couple, but the one that I usually go to is the one I'm using right now. So if you just do a top, this is pretty much available in every version of Linux. This is going to give you some stats. Top should probably be one of the biggest consumers of CPU when it's not doing anything. This number up here is what you're wanting to look for. Now, if you start using your Wi-Fi a lot, it starts slowing things down, come in here and check this number. It might be that dongle causing problems. If we go over to Fluid and let's just add a file, we're going to upload a sizable G-code file, 26 meg. We'll let that upload, and then we'll take a look at top. So we see 10 or 11%. That's not out of scope. You just don't want to see it running at 25 or 30 when you're trying to upload. So just be aware of that. I'll leave a link to the USB dongle that I recommend. So there's everything you need to know about the Linux portion of this and getting things connected. Now there's a couple different ways to tackle this, like I said before. You could use that Ethernet cable, but you'd still have to know the IP of the board. You could use something like Angry IP Scanner or get on your router to figure that out. That way you could get straight to Fluid and start configuring Klipper. But we have a lot of other things to do here. It does have Klipper installed already, so you could start configuring it, but we want to take a look at different options we have with Klipper, as well as Mainsail. But that's a whole bunch of different info that's going to be in the videos to come. So that's it for today. Hopefully you found this helpful, and I'll see you really soon on the next one.